So today, I will be discussing the two different ways of titration used in iodine, which is the iodimetry titration and iodometry titration. So what is iodimetry titration? It is a direct method where iodine acts as an oxidizing agent to titrate reducing agent. It means the titration or the titrate we will be using is the iodine solution. We'll be putting it in the barrette, and in our conical flask or the Erlenmeyer flask, we'll be putting the sodium disulfate, which is our reducing agent. So in this process of iodimetry titration, we will be putting starch or our indicator and the sodium disulfate, which is our reducing agent. And from this, we'll be putting next is the 2 to 3 drops of oxidizing agent, which is the iodine solution. And from these 2 to 3 drops of iodine solution, it will have a chemical reaction or the color changes, which turns to blue. And that is our endpoint of iodimetry titration. Next is the iodometry titration. It is an indirect method where iodide is oxidized to iodine, and the iodine is titrated with sodium disulfate. So in this process, which is the iodometry titration, is that it will be inverse. We'll be using the reducing agent, which is the sodium disulfate, and we'll be putting it in the barrette. While in the conical flask is that we'll be putting the iodine solution, which is our oxidizing agent. Now, in this one, we'll not be putting first the starch or our indicator. So, we'll not be using the indicator or the starch first, but we'll put 2 to 3 drops of sodium disulfate or an iodine solution. So from these 2 to 3 drops, it will change colors like brown, then yellow, until it will become pale yellow. And from this pale yellow, we'll be putting now the R indicator, which is the starch. And from this starch, it will become a blue-black, which is the reaction of the starch. So that is blue-black. And from this blue-black, we'll be putting now the 2 to 3 drops of sodium disulfate. And from this, it will change color again. It will become colorless. And from this is the endpoint. Now, let me give you the image of the process of iodimetry. Now, our next discussion will be the two analysis, which is the gravimetric analysis and the volumetric analysis. Now, first is the gravimetric analysis. So, gravimetric analysis. It involves determination of the mass of an analyte or its precipitate. Procedure. A sample is reactive or reacted to form a precipitate. The precipitate is filtered, washed, dried, and weighed. The concentration or purity of the analyte is determined by mass. In this graph, precipitate or the excess of a sample solution, which will be using a filter paper. And from this filter paper is the precipitate or the excess of the solution. And from this, we'll dry it and wash and then weigh this excess or solid form. And from this result, we'll be using now the gravimetric analysis to determine the results, to determine the solution's result. And now is the volumetric analysis. It is the volume of a solution is used to determine the concentration of the unknown solution. This technique requires known reaction rates, a detectable endpoint, no side reactions. So an example of volumetric analysis is the titration. It will take much more processes to have an endpoint or have a result. And from this endpoint is that from this endpoint, we're now conducting the volumetric analysis. The next topic will be discussed by Queenie Marie Buton.